All right, everybody, lesson 1, polynomial review. So just reviewing what a polynomial function is, it's defined by this equation, which seems super complicated, but in reality, it's just describing coefficients and exponents. So you're going to have some coefficient, and you're going to have some exponent, plus another coefficient and some exponent. So A is the value of the leading coefficient, and A0 is the value of the constant term. So we've got a couple terms here. The one here is called the exponent, and we've got the leading coefficient. And it's the leading coefficient because it's the polynomial with the highest degree to start. So you notice it goes 3, then 2, then 1, then 0. Now the last term here is called the constant. A polynomial function consists of one or more terms, which are separated by positive or negative signs, or addition or subtraction. If you've already seen polynomial functions in one variable, for example, quadratics, they're polynomial functions as well. Same with linear equations, same with just constant terms. So quadratics, linear equations, and constants. So to go over kind of what are or are not polynomial functions, this first one has a negative exponent. So it's not a polynomial function because of that. And the next one is not a polynomial function because of this root x. So variable under the radical, you could say. Now, if you recall from our last unit, the root of a number gives you a fractional exponent. Okay, so that's no good. As well, x minus 3 over x minus 1 is not a polynomial function because of a variable in the denominator. So that would lead to non-permissible values, or asymptotes. So in a polynomial function, all coefficients must be real numbers and the exponents must be whole numbers. So no fractions. So let's go through and predict whether these are going to be a polynomial function or not. So pause the video, try and fill out the chart, and then click play and see if you're good to go. So the first one, I see a radical, so this is no, and because radical, that'll be my reasoning. A radical, again, will lead you to a fractional exponent, and that's not a whole number, so not a polynomial function. All right, the next one, does it look like a polynomial function? Yes. The degree is 4, that's the highest exponent. The leading coefficient is 3. And the constant, there is no constant in this, it's 0. How about the next one? No. And the reason is the variable in the denominator. The next one is a function. It's not a quadratic function. The degree is 5. Okay, 5 is more than 2, so the degree is 5. The leading coefficient then is not going to be 3, it's going to be negative 2, because that goes with the highest exponent. And the constant, we do have a constant in this, it's 4. How about the next one? Yep, the degree is 4, the leading coefficient is negative 4, and the constant is 3. The next one, no, because of fractional exponent. The next one is no, because of the negative exponent. And the last one, no, because of a exponential function. It's not a polynomial function, it's an exponential function, but it's not a polynomial function. So let's go into graphing polynomial functions. And we're going to examine a bunch of different types of graphs. And a couple things we need to look out for is the end behavior. And that means what's happening when you read left to right. Okay, so even degree polynomial functions. And you've seen lots of even degree polynomial functions, quadratics, in fact. All right, now this is a positive x squared, so we're going up. A negative x squared goes down. This is also quadratic. This is quadratic. This is quartic. So if you put in x4 into your calculator, like y1 equals x4, you are going to end up with the quartic. And this is a negative quartic function. And what do you notice so far about like a negative quadratic and a negative quartic? They both go down. And what do you notice about a positive quadratic and a positive quartic? They both go up. All right. This is still a quartic function because of our highest degree 4. But what do you notice about the ending points of your line? Again, they still face up. This is a negative quartic. And what do you notice about the endpoints? They both face down. So let's think about some end behavior. And one thing to note, this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So you need to know. Okay. So the sign of the leading coefficient. So let's look at our positive leading coefficients. So which ones are the positive leading coefficients? I'll highlight them in yellow. So this is a positive leading coefficient. This is a positive leading coefficient. This is a positive leading coefficient. And this is a positive leading coefficient. So let's look at the endpoints. Where are the endpoints for positive leading coefficients? Well, they all start in quadrant 3 because we're reading left to right. Okay? And they end in quadrant 1. So the end behavior is they start in Q3, and they end in Q1. And both ends are up. Okay? The negative ones. Let's highlight the negative ones in green. So negative x squared, negative x, and negative x. And where are those endpoints? Let's go down, 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 and down and down. So these ones start in Q3. Q3. And they end in Q4. So both ends are down. Okay? And the last thing we're going to talk about is odd degree polynomial functions. So that means your exponent is an odd number. So we've got linear, linear, cubic, 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 quintic, quintic. So quintic means 5. Okay? And let's go through the end behavior. So if the leading coefficient is positive, let's look at the positive leading coefficients. So that one, that one, that one's positive leading coefficient, and that one. Just going to delete that. So all the highlighted in blue. Well, all the highlighted in blue start in quadrant 3 and end in quadrant 1. See that? So starts.
Could Emily Poulin and Isaiah Barber please come to the office?
And they end in quadrant 1. So if you look at the arrows, they're kind of doing that. And the negative ones, let's highlight in yellow. So that's the ones we haven't done. And what about their end behavior? Well, they start in quadrant Q2, and they end in quadrant 4. So the left side goes up, and the right side goes down. You'll see that they're opposite. So positive will face either the same direction and even will be in the same direction, and the odd polynomial functions go in opposite direction for their end behavior.